Hello everybody. Welcome back. I hope you had a wonderful winter break. But now it's time to get back to work. I know. So today we are starting reverse. In class you guys did 1 and 2 step inequalities. Like just a worksheet on it. So our first video is actually about multi-step inequalities because that's what our unit is on. Inequalities. So this can be a nice little ease into because it's very, very similar to equations. So a lot of the stuff you already know too. So let's go ahead and get started. So day 1 notes, multi-step equations. Let's start with the vocab. An inequality is basically a comparison of two expressions. Okay, so remember expressions are variables, operations, numbers, all that fun stuff. A solution for an inequality is values, okay, plural, for the inequality, and that inequality word should actually be for the variable, values for the variable that make the inequality true. We're going to be using inverse operations, which are just operations that undo each other, and we will be using set builder notation again, okay? So remember, that's just, we have these like braces, these little curly Q things. We put the variable that we're using in there, the line, and then we write the rule for the variable. So, for example, x must be greater than or equal to 3. Okay, that's the rule. So that's what we actually write in there. Okay? It's not just telling us what x is anymore. It's actually telling us all the things that x can be. The set of values for x. Now it makes sense why we use set builder notation. Alright. Ooh, it's jumping all over the place. Well, that did nothing. Sorry. Oh, before I even go on, good lord. Okay. Set builder notation, here are some examples just to remind you. So when we're using equations, we would just say, well, x is 3. But now that we can have more than one solution, we can write that just what it's greater than or equal to or less than. Okay? This should be review for you. Alright, we solve inequalities just like we do equations. We use the inverse operations and we follow SAD-MAG, where we undo addition, subtraction first, then division and multiplication, any exponents, and then the groups. Okay? Now, what's different with inequalities is that there is this special rule that if you divide or multiply both sides of the inequality by a negative number, you must flip the sign of the inequality. Okay? So, let's go ahead and try this one. This is a 2-step. 1 and 2 step, we did the stuff in class, like the worksheet in class. That's really all we're going to spend on it because your main focus on this is going to be multi-step. Okay? So, and you need 1 and 2 step in order to do multi-step, so it works out. So we're going to solve, we're going to check it, we're going to graph it, we're going to write it in set builder notation. A lot of stuff. Also, graphing on a number line isn't so much an algebra skill. We're doing this more to review. Okay? So you're not going to see as many of these line graphs anymore. We're actually going to be talking about how to graph it on a coordinate plane later on this unit. Okay? Well, let's go ahead and solve this. So we're just basically trying to get our x by itself again. So the very first thing, following SAD-MAG, we're going to undo this minus 12 by adding 12 to both sides. I know it's really tiny. I'm not sure why, but... So then the negative 12 and the positive 12 cancel out, leaving me with just 3x is greater than or equal to 21. Then I go ahead and divide both sides by 3. Now, because it's a positive 3, I don't flip my sign. So I can leave it the way it is and just say x is greater than or equal to 7. That's my solution. Okay, that's what I'm going to write down because that's telling me what all the solutions are. Okay, so x is greater than or equal to 7. Now, I can check that to make sure it's correct because it's saying that it's any value that's greater than or equal to 7. I'm just going to pick a number greater than or equal to 7 and plug it into that original inequality. So I'm going to pick 10. That's bigger than 7. And it's a nice round number. So I plug it in for the x. And what I should get is a true statement at the end. Okay? So 3 times 10 gives me 30 minus 12 gives me 18. 18 is in fact greater than or equal to 9. That's why it says greater than or equal to. So it's true, so I know it's my solution. So x is greater than or equal to 7 is my solution. So to write it in Step Builder, I just use a brace, write the x, write a line, and then write x is greater than or equal to 7. Now to graph it, I'm going to put a closed circle on 7. I'm using a closed circle because it's equal to. So we're going all the way up to 7 and including 7 as a solution. So closed circle goes there, and I just point to everything smaller than x. A lot of you have probably heard of the rule, like just write the arrow or draw the arrow the way that the... Oh wait, I totally did this one wrong. Okay, don't do this. Why did I say it was that? Ew. Why am I so weird? Alright, let's fix this. I know my video is going to be really long. Sorry, it's the first one of 2018. Cut me some slack, please. Let's fix this, because it's supposed to be greater than. So I'm going to do a closed circle. Make sure it's filled in. On 7. Right there. And then I'm going to have the arrow point to all the numbers that are actually greater than 7. So over here, I'm going to change my arrow so it's aesthetically pleasing to everyone. Because, here we go. So, closed because I'm equal to, and I'm actually, like 7 is a solution. And I point that way. If it wasn't equal to, I would just have an open circle there. Okay? So, that's my graph. That's my step building notation. That's my solution. Okay? If you hear noise, it's my dog in the background. Sorry. So yeah. Let's go head on to multi-step. So, just like with equations, we add on a little bit more. Remember, this multi-step can include just multiple steps. It could have distributing, it could have combining like terms, it can have both, it can have variables on both sides. Okay? So the way we do it is we distribute first, and we combine our like terms that are on the same side of the inequality sign, and then we solve. And solve means to get the x's, or the variables on the same side and the numbers on the same side, and then isolate that variable. Okay? So we're going to go ahead and do this example together. So first thing I need to do is distribute. So 5 times negative 3 is negative 15, and 5 times negative 5 is negative 25. And then I'm just going to go ahead and solve just like a normal two-step. I'm going to add 25 to both sides. So I get negative 15x is greater than or equal to negative 3. Let's scroll down a little bit so you can see. How would I go back to the big screen? That might be helpful. If you would just go away. Now I need to get rid of this negative 15, so I divide both sides by negative 15. Warning though, I'm dividing by a negative number on both sides, which means I need to flip my sign. So even though negative 15's cancel out, I get x, and negative 3 over negative 15 reduces to 1/5. It becomes x is less than or equal to 1/5. Okay? So please be careful. It's one thing that gets overlooked so much because people go too quickly and don't check their work. Or they try to do stuff in their head, and it's like something that just gets overlooked because they're more worried about the numbers. They can have everything right, but they're saying everything's like greater than it. That's not true. Okay? So go ahead and make sure you slow down with this and double check your work. You could check it at the end, just like we did on the first page. Okay? Now to write this in step builder notation, I just go ahead and put an X in front of it, the line, and some braces. There we go. Okay? You guys are going to try this one on your own. It's got some combining like terms in there. Why is this? Got some combining like terms in there. So you will have to do that a little bit. And yeah. Go ahead and try. You can pause the video now or you can wait until the end. It's up to you. We're going to go ahead and move on to example 3. Okay, so example 3, jeez, this thing does not like me today. So example 3, remember, first thing I'm going to do is distribute. So I got distributing, I've got combining like terms probably, I've got variables on both sides. This is like the epic multi-step inequality. Okay, so we're going to do everything in this, which is great practice. So first thing we do is distribute. So negative 2 times x and negative 2 times 3. Give me 4x from the front. That tends to get dropped, so don't forget it. 4x minus 2x minus 6 is less than 5x plus 6. Now on this side, I have like terms. The 4x and the negative 2x can combine to make positive 2x. I don't have any like terms over here, so I'm going to leave it alone. So now I'm just going to go ahead and get all the variables on one side. So I'm actually going to subtract 2x from both sides. You could go ahead and, you can start either by subtracting 2x like me. You could subtract 5x from both sides and get your variable on this side if you want. You could add 6, you can subtract 6. It doesn't really matter because it will all work out in the end, to be the same thing. So how you want to proceed from here, the order that you do it in, is totally up to you. You should still get the same numbers I do. The only difference might be negatives and positives, but they'll all work out by canceling or not adding, but canceling out or working out that way, whatever method you choose to use. Okay, so back to what I actually did. I subtracted 2x from both sides, giving me negative 6 is less than 3x plus 6. So then I subtracted 6 from both sides. This canceled out. This gave me negative 12. And then I just go ahead and divide both sides by 3. And because it was positive, I don't flip. So I get negative 4 is less than x. Now, what I was saying at the beginning of the video, before I made the wrong graph, you guys probably you might have heard the rule, oh, when you draw your graph, you can just point your arrow for the graph the same way your inequality sign is pointing. That doesn't work anymore, because sometimes you get answers written like this, where the variable doesn't come first. That arrow is not telling you to point to everything smaller than negative 4. What that actually means is if you flip it around, it means x is greater than negative 4. Okay? So you need to forget that rule completely because it's going to mess you up. Okay? It's more important that you guys understand what these inequalities are actually telling you, not a shortcut way. Okay? So make sure you fully understand what's going on. That here the x is the bigger number because it's greater than the negative 4. Even here, x is still the bigger number. It's saying negative 4 is smaller than x. Okay? It's good for you to have a firm understanding of that. Okay? Now all I had to do is write it in step builder notation. And I could have left it like this with the negative 4 first for my step builder notation. That'd be totally fine. Okay? Last one, on your own, I did give you a doozy. However, it's very doable for you. Distribute, combine, and then solve. Okay? Just has a few more terms than anything we've done. Alright? But I have confidence in you. You can do it. Do it well. Okay? If you have questions, write them down. Other than that, we'll go over it in class, and yeah, I'll see you then. Bye, guys.